Hey, hi everyone. So today the agenda for today's session is like we are going to cover the remaining sum crux of the arrays. On note of that, let's start with our first problem. Okay, let me share my screen. So today's problem. Okay, so let me just increase the thickness. All right. So first problem. First problem is saying here is like you have given an array. Okay, array of the numbers. It seems to be like, for example, 1 2 0. Think of these things like it's one of the great problem, but easy but great ones. So numbers are given is in the form of like 120. 120 is a number. That means this is representing MSB, this is MSB, and this is LSB, right? LSB. So it's the same thing. This is MSB and this is LSB. What is MSB, LSB? Most significant digit. Okay, MSD. Let's make it not bits. And most significant digit and least significant digit. What you have to do? Nothing. It's simple. You have to just add one and return the modified array. Okay, add one and return the modified array. And think of like what are the things we can make it up properly to solve this problem. Let me just open this problem statement in Leetcode also. Okay, so let me ask you this way also, like what are the various boundary conditions you can think of to solve this problem? Okay, so that's a simple, right? That's the problem statement is very simple. If you can go with the problem statement, it's saying this thing. See, you are given large integer represented as an array integer array digits, where digit I is the ith digit of the integer. Order from least left to right order, LSB to MSB. Okay, it does not contains any leading zeros, right? So this is what about the problem statement. Okay, now if you can see 1 2 3, it's added and giving 1 2 4, 4 3 2 1, it's added and giving 4 3 2 2. Simple. So what are the various approaches we can think of? So one thing what we can do, which we can think of is like, hey, this array has been given to us, convert into the given digits. Okay, it's a proper number, proper digit number, and add 1 to it. Okay, 120, and then transform again. Okay, it's like 1 to 1. This is one elegant way and unique way. What's the second thing? We can do it up here. The second thing which we can do it up here is like iterate from back. It's like iterate from back, like 1 2 0. Iterate from back. What we can see, you can see the number here. Okay, make sure to have one carry also. The simple addition. Okay, simple addition. Those who don't know, I am just writing for them. Simple addition. Carry. Okay, so whatever the, let's say this is digits I plus carry plus what? No, sum. Okay, so this is sum plus equal to digits I. What this sum is? Sum is like digits I only. Okay, so we have just done this digits I sum. Instead of saying this as digits I, firstly just take this sum directly. Sum will go with digits I, carry. Okay, that's it. These two things. Now it will have modulus of 10 and division of 10. Why so? Because the numbers are from 0 to 9. Okay, these cells will have the numbers from 0 to 9. So what we can do, We'll do modulo from 0 to means modulo from 10, okay, divided by 10. Modulo of 10 is going to give you sum. Division by 10 is going to give you carry. It's going to means this sum is basically the number. It's representing the number which is going to come in digits of I. All right. This carry is going to be updated here, okay, and this is going to be used up here, okay, everywhere. So what is the main case which we are looking here? For example, let's say we have 999. What are we going to do? We have to do plus 1 here, okay? So we got 10. Okay, so 10 is like digits of I. What will be the digits of I here? 1. Okay, digits of no, digits of I will be 10 mod 10. 10 mod 10 is what? 10 mod 10 is 0, correct? Here 0 will come. After that, 10 divided by 10, carry is equal to 1. So here carry will come as plus 1. 9 plus 10 again. So let me write the answer up front also. Yellow is saying you the answer here. Okay, 0. Okay, then what you are going to do? The plain addition, right? 9 plus 1, 10, 0. Carry addition. Carry is like 1. So 9 plus 1, 10, 0. Carry addition. Now, one more thing we saw. This is the worst case, okay? So carry. So carry either be 0 or either be 1. Only two values. Carry is not more. Or if I want to say overflow condition, what will be the overflow condition? Overflow condition, if I want to say, it will be when the arrays are having all 9s. Why so? Because we need one extra space at this point of time and mark everything is 0, and this carry is going to be moved here, which is 1. Agreed? Now, this is true. The above approach is also true. But let's see one elegant approach. What's the problem? The problem, there is no problem. But the thing is, like, you are doing plain sum, addition. So let's try to do something innovative. All right. So let me tell you. I was opening the solution for multiple languages though. Okay, that's why we will do later. This is the array given to us. Let's say 191. Okay. 190. What I will say, I will start from back itself. From back, what I will do, I will see the numbers are from 0 to 8 or not 9. I am not looking for 9. If the numbers at any cell, means at any cell we encountered, let's say for this cell, we encountered numbers from 0 to 8. What I will do plus 1 and return the array upfront. For example, this is 1, do 1 and return it directly 192, because the number lies between these ranges. What if not? 199. What if not? What I will do? See, think. So first step is like, if the number is lying between 0 to 8 inclusive, I'm going to add 1. What if not? I will make it as 0. Proceed further. Proceed backwards. Okay. Again 9, 0. Proceed back. Here I got 1. Okay. What our algorithm is saying? Our algorithm is saying is number from 0 to 8 inclusive. Increment 1 and return. Okay. Return. What if? Okay. These are the two conditions. Condition 1. Condition 2. Okay. What if we didn't meet these two conditions? Because these two conditions can occur in the loop. Agreed? Can occur in the loop. So what if these two conditions are not getting occurred? Then what we'll do. For example, what will be the scenario or the case which we can think of? So all nines. This, so I'm starting from here. This is 9, make it 0. This is 9, make it 0. This is 9, make it 0. I came out of the loop. When I came out of the loop, there are two things you can do. First and second. First thing is like create an array of size greater than 1 given by the given input array. Correct? Mark this as 1 and all these values will be copied here. This is first approach. Second thing, what you can do? You can do the same one. Create a new array of size greater than 1. Mark it 1 here. No need to iterate and copy. Why so? Because by default it's 0. So the time complexity, if we'll talk about here, it's like order of n, because sometimes the case when the condition 2 is going to become, we need to iterate in the worst case to the whole array. But when condition 1 is going to become, it may or it may not. Correct? If the condition 1 is coming, it may not iterate. It will just break it up over there itself. It will return the result itself. Let me go through 999 case 1 again. Okay, you know that I'm starting from back. Okay, now from this back, these are 9. If I encounter number from 0 to 8, I will increment by 1. But if I not encounter 0 to 8 number, if I'm encountering 9, I will make it 0. Proceed backwards. I'm encountering 9, make it 0. Proceed backwards. Encountering 9, proceed 0, make it backwards. So just think of right now this plain solution which we have think of. When you have given 999, result will be 1000. Okay, that will be the overflow condition. So can we say once the loop is completed, and when we came out of the loop, that means we reached to a overflow condition, right? What will be the overflow condition? Overflow condition will be like 0, 0, 0, and this position, the last position or the MSD position, will fill with 1. That's it. Okay. Let's proceed towards the code. Okay. Now here, what we are going to do? We are going to start with the int I is equal to digits or minus 1, I greater than equal to 0, I minus 1, right? If what we'll have if digits of I is less than 9. If digit of I is less than 9, what I will do? Let me create this digits of I plus equal to 1, right? And return digits. Else what I will do? I will just make digits of I equal to 0. That means this is for the 9. Once the loop is completed, int res no int digits dot length plus 1. Can I write it up? And res of 0 is equal to return res. Let's see, it's working fine. Okay, 1 2 3 1 2 4. Second case 4 3 2 1 4 3 2 2. Third case 9, which is 1 0. Let's check for 999 because we have checked now. 9 9. Okay, let me submit it. Right. If you're going to the new window, as per the new Leetcode interface, the solution is accepted. Else, it is not going to allow us to submit the solution. Right. So let's see the solution in other languages also. C++. Okay, let's see in Python 3. We have, because we have already seen that. Now, what it's saying, firstly, it is calculating the length. And it's starting from the starting to end. Okay, it's starting from starting to end, right? So once it's starting from there, it's checking like all the nines at the end of the array to zero. So the same thing. If it is 9, it is making it 0. Otherwise it is adding it up and returning the digits. What if all the nines are we have? We are just adding, is putting ones in the front and returning the digits. That's it. This is for the Python one. And C++ solution. Let me see C++ if we'll have here. No, so let me just take it up here itself, because we can't code all the solutions. Okay, submissions. Have C++ submissions. Submissions. This is a C++ submission, which we have coded it for the sum and carry thing. You can see it's what it's doing. It's just creating the sum and pushing the values. It's like one of the non-optimal solution in my opinion. But to be honest, we have to cover up all the approaches which can cover. So this is the way we have covered. What it's doing, it's creating sum and carry. Okay, sum and carry and putting the values. And till the stack is empty, it's just popping out the values here and returning the result. All right. So this is the first problem.